Hello, in this video we will learn how to use full text search in PostgreSQL. We are sort of continuing on this project from the previous episodes of the series. You don't have to watch the previous ones if you only want to learn this. We will build on top of this existent sort of database arrangement. This is what you would actually do in the real world, most likely. Sometimes you start from scratch, but really usually these features come as a later addition to things, so it's a great place to start. But if you want to learn more about PostgreSQL, how to set up migrations, how to set it up in general, all these different types like JSONB and these custom types, you can watch the previous videos in these series. But in this case, we'll essentially sort of do a full text search arrangement. We will be using vectors, which can help you create these automatic indexes and do more like a Google kind of a search. So you have some kind of a phrase, you can include or exclude things, and you start searching like that. So we'll create a custom type for that. We'll do the whole setup, and we'll start building on this existing products API. We have a product table. It already exists with all these fancy arrangements. Now we'll add a bit more to it so we can have that sort of proper search of those different properties in a full text mode as such. So let's begin, and let's start by adding a little additional property to this product table or product field in the whole arrangement here. Now, before we begin with the product, as usual, you just need a few things installed for the actual thing to work. Just as any other feature of PostgreSQL, you just need the NpgsqlTsQuery Entity Framework Core, PostgreSQL, this package, and the design for migrations. The Open API one is only because we're using minimal APIs to kind of test it out and put those queries together. But other than that, you don't need anything else, no additional things in this case yet. In the future videos, we'll cover some RAG arrangements and all those things, so you might need a few more things, but for now, just all these things will suffice. As far as properties go in this product.cs, we have a little product class to define essentially product table. And we have a few other things. This is defined in JSONB column, product metadata part, well, a column in the table products. But for this search vector, we will actually be using all the existing columns, right? We will just add another sort of property, another column as such, which is a vector column, a vector property here. But it doesn't actually hold any data as such. It just holds sort of bits and pieces on how you can actually search the existing columns, the existing properties. So it might be name, it might be metadata, it might be tags, whatever it may be, whatever you actually define in there. So you don't want to define everything, and we'll get to that in the app database context, in the AppDB context as we call it in this project. We'll get to that later, but in the actual property, in the actual table as such, you only need to define one thing. Public, of course, as it usually goes, NpgsqlTsVector. Now, you can actually see there's quite a few things that you can define like this. It's quite interesting. We'll get to those videos probably later on, but this is probably the most useful and the most interesting out of all of them. And we'll call it just simply search vector. We could have actually taken that suggestion, would have been a bit quicker, but let's do search vector like that and get set. And we can do a little nullable default null like that. So as far as the property definitions go, you have a search vector, and it will be able or not be able, depending on how you define it later on in the context, search through all these things. Might be stock, probably not. We certainly don't need that. might be price. Well, again, certainly don't need that. Price is price. We're not going to do full text on a decimal. So mostly what you'll be using it for JSONB columns, like product metadata. Lots of things going to be in there. And for something like a name, right? Because name is a string, so you can search part of a string, say metal parts, and the product might be called something metal parts of red color or something of that nature. So that's how you define it. It's full text, so we're sort of looking at the text arrangements. And something like tags, you probably don't need that as well, because you have tags listed as an array, or for example, we have a size. Now, a size is string array, but if it's an array, you can easily do that just by checking if it contains something. So you probably don't need full text. Full text, when you have huge pieces of text, sometimes smaller pieces of text, but like string name. You might also have description, which we don't have here, but we do have metadata, which will be a massive JSON string and will be very useful when searching through that. So now let's get to the AppDB context and set some constraints and sort of search arrangements for this vector. So now we're in the database context. Let's go up here a bit. Let's zoom it in a bit more so we can see it perfectly. We have AppDB context. Again, whatever you want to call it, you call it. Whatever your context is, that's going to be the name. In this case, the default one, of course. And we have our database set, the table as such, products. And then we have all the previous definitions. We have all the indexing methods, algorithms, and such. We will actually have it the same thing for the search vector. Quite interesting. But let's set it up first. So again, just like anything else, we have entity, and then we have property, like this. And the property in this case, let's see, P search vector, we can do that, we can do that, we can take the suggestions. Never be afraid to take the suggestions. It's always a good idea to start from something rather than doing it from scratch. No point in wasting time. But this is sort of defining it to a point, and not a very useful point. What we actually need to do here, and we don't even need the column type yet. We won't even need it ever. We need HasComputed. See, HasComputed column SQL, like that. And we don't have any sort of type. We don't have anything like that. We'll just expand it and we'll go bit by bit. Essentially, it's giving us lots of suggestions, but essentially you can set different ways of which property you will actually be searching for and how it will be. So does it start from name? Does it start from description? Does it start from tags? We won't be doing tags because, as explained previously, there's no point in that. But it will search essentially throughout the whole table, or the whole class definition, if you're looking at some sort of C# perspective. From the actual SQL as such perspective, the database perspective, then that would be the table. So we have this, and let's do 3 of these, quite a few of these we need. So 3 at the start, 3 at the end, and now we can actually write a few things, which isn't very easy because now it's just text and it can break very easily, and we'll see how it goes. If we get an error, that's perfect. If we don't, you can always go to the comments and ask about different errors. There will be some answers to those questions, or you can join the Patreon. The answers will come a bit quicker on there. So we can set weight, and I think in a few moments you'll realize why we're doing that. So we can actually take a suggestion here. We will kind of remove it a bit. These are sort of logical statements here, or it is or, And you could also use, but really if you're doing full text, you're not gonna sort of do if statements here, right? So it's gonna be all or. But the thing about it is you start with A, you go to B, and you go to C. So whatever search term you use, it will first try to look at the name, and then it will try to go to metadata. If we had description, perhaps metadata would be C. This would be B. So this would be C rather, and meta and description would be B. So you start, if it matches the name, if it matches the name exactly, that's what it will give you, the name exactly. If it doesn't, then maybe it will go to description, maybe it goes to some other bits and pieces of your property is, and it will pick from that when it actually matches something decent. Or in the end, it goes to metadata. If it matches something from there, at least to a point, then it's going to use that. So that's what we have. Let's now do another quick thing. And in fact, we can actually copy paste. We haven't doing that here in this video series because everything was new, but you should always copy paste these things, because now we need to add a method of indexing gin, and we're just adding it to the search vector. So that's what we are doing now. And after this, we can actually run migration. Unlike some of the other setup, we don't actually need to do anything sort of database specific in program.cs with the builders and things. So we can actually start looking into it from a sort of query perspective. Just something to note here, we have in the actual definition, HasComputedColumnSql, the main thing here is the tsvector. This is sort of making your search term more accessible to every variation in the actual table. So it's lowering the case matching and whatnot. It doesn't remove the words, and basically that's how it goes. But realistically, the main thing is right here. In metadata, for example, it's not going to search the whole thing of metadata. It's going to go to brand. If you want the whole thing, then you do it as a whole thing. But the main thing in the end is the weight. So whichever column you prefer to be the main column, and usually it will be title name for a product. In some other case, it might be something completely different, but that's the sort of first one. That's where we start. And that's going to be the first output as such. And then it's going to be the metadata or whatever else you have in there. And of course, don't forget that this is quite interesting here. In metadata, we are still working in a single column here, metadata. But because this is JSONB, you can actually go into these different bits and pieces of it, different properties of the actual JSON arrangement. So that can be quite helpful. But again, there's quite a few ways to do this. And you can also define the language, which can be quite useful. You will be doing English usually, but there is something to kind of go deeper, and perhaps we'll do an additional video on this, working with languages, and perhaps we'll touch on that a bit more when doing the RAG arrangements for the sort of AI embeddings, if you will, simply put. But now let's look at some queries, and let's run a little migration after this, because it's all set up. We're not going to get into the migration this time. If you want to learn more about migrations, you can go watch the previous videos. The first one in this series explains sort of in detail how migrations work in EF Core, and specifically in PostgreSQL. Now for some queries, let's start with a very basic one, yet probably something you would actually go for in this sort of a case. So let's just do a little app map like this, map get, as we usually do for the queries with search at least. If you look at the other videos in this series, you might see we have post for searching because we need the body essentially to pass those certain things. It just doesn't work with search. And sometimes in search you will use body to search products, to search people, to search things in your database. So let's do this. We have product search and we'll add a little query. We'll not take that suggestion for sure this time because we are actually using this sort of full text search, proper one. You might say Google style syntax you will be using in this because it is certainly possible with this arrangement. But besides the setup, there are some different ways that you actually search. So let's add a little query here. So it's just going to be basically search text, the text you're using for the actual search. And then let's do as usual async. And here we take string as query and appdb context, and then we can take the suggestion and get rid of this. Because we need the appdb context, bdb context, and then we will just return something essentially on this one. Well, let's do it like this. Let's remove this, return, await, and now we can actually start the search. So let's go to db context, products. Usually we go with as no tracking if you're interested in that sort of arrangement, how you update things, how you have to do queries, where you actually need to do two lists, where it's not useful and where it's useful for performance reasons, and just sort of basic good practices with these arrangements. Watch the first video of these series. So we can go with no tracking and let's get rid of this. As no tracking, and then we can actually do the search. So just as any other search, we're basically using a EF Core, link kind of an arrangement. So it's where, and then we need to do P like this, a little lambda expression. And this is where it gets sort of a bit more interesting. So let's say P, and then the search vector, the vector itself, matches something. So we're not using the vector inside other sort of properties. We're starting from the vector, but that will need to match some specific thing, and it's not going to be just query. It's going to get a bit more tricky than that because we set the language and we set the casing and we set A to B, so we kind of need to search based on that as well. Now we will use matches because we need to find specific matches, and let's do EF. Right, we're sort of getting to that EF Core specific syntax. So it's all database level still. We're not putting anything to memory. We're working with the actual vector. And then we do functions, right? And with the functions, we'll use WebSearchToTsQuery. So we are using essentially web search arrangement for the query, and we can actually now take the suggestion. So that's going to be to list sync. We don't need order by descending. We can add that, doesn't matter, or maybe it matters in your case, but we don't need that. So EF functions, let's see, maybe we sort of took a bit too much of that suggestion here. Let's go back. We actually don't need that. We don't need it to go that far essentially. What we do need, we need to specify the language we use, English, and then go a bit further like this. And then we have the query. So query like that, and I believe we need to close this like that. And put two strings. So we have where starts here, and it closes here, and then matches EF Core like this. And let's say to list async like that, and that should be perfect. So now we have all the matching things, and we essentially start from the vector when the vector matches one of the search queries. Now, there are other ones. We will take a look at some other ones as well. But basically, you need to match a certain kind of query taken from that. There are options to this, right? So just as the setup goes, there are options in the actual query, and that's where the difference is between that sort of default one and this one. So say matches, web search query, and then at that point, from AppDB context where we set it, it will go from name to maybe description, maybe not, maybe metadata, maybe not, A, B, C, D, whatever you have. And it will go from there and it will match that certain default language specification as well. So now let's take a look at something a bit more perhaps difficult, or perhaps just more details in it. So now let's actually do a ranked search, which will search by those rankings specifically that we set up in AppDB context, the ABC and whatnot. So let's do another map get like this, and we are actually offered that search ranked query. That's good, that's good, that's good, that's good, that's good. And let's take it up to this point. Yeah, that's good enough. So something like this, and then open it up like that. And let's do a more complex query as such, or in some ways something that you can actually expand. So let's do a variable TS query like that. Let's get rid of this for now. So you can set a separate entity here, and obviously it doesn't return, so there's some errors. But this can be useful if you want to then later, based on some perhaps parameters and such, expand on this query. And you can do and additional perhaps text. So maybe you have sort of synthesized selection of filters. So you want to put it as a such query. You have your first text search, and then you have and you might have your other options added to this whole arrangement. As you can see, you can add quite a few options and or to this suggested query. Now, let's keep it a bit more simple in this case. Let's do a little return like this, await as we usually do, DB context and products, and as no tracking as we usually do as well. And let's take this suggestion. For example, this is exactly what we want to do. Again, you can separate it out just like you separate the whole setup builder. We looked at that in a previous video. We can actually go up here. So it's similar to like data source builder, where you need to enable a few things, map to enum. Watch the previous video if you're interested in this. We basically store enum as a full enum, very useful for public APIs. You can store it as a sort of custom type, if you will. So it's kind of the same thing here. You can actually expand it. You don't have to do a massive one-liner. And if you have more sort of query options, very good sort of arrangement to go with in this case. So we might have something like this, map get, TS query, we have a query, and we might have a second query at that point. But then essentially we just search this, and we can also do something like this. To select we kind of don't need here. Let's simplify this a bit. So let's just do order by like this, or order by this. Oh, let's take that suggestion. Why not? We have order by this descending, and then we have P, again the same as in where, and then we will have search vector, and we will have rank. See if we can actually we're not doing that. That's not how we're doing it. So order by descending, and then P, and then search vector, and then rank, and then TS query. Now, as you can see, some of these suggestions, they do get sort of nonsensical at times. They make no sense at all. They use just completely wrong syntax. But for the order by ascending, we go with the actual vector, because essentially it's kind of searching all the other properties, which what you are returning is almost like you may think of it as a view in SQL Server, quite a popular thing. So you have a bunch of tables, but then you have a view, and this is not exactly the same as a completely different thing, but you might think of that as sort of taking data, but the actual definition is that search vector at that point. So we take rank of tsQuery, that we take the A, B, C, and D and all that. And then we can do all the other things like take 10, for example, and then select something. That's not what we want to select, but let's say select new. I believe that should be good enough. And like this, let's say remove that, and we will have so whatever you want. Let's take that suggestion, why not? And the rank, so it will be ranked, and then on your front-end arrangement you might rank it based on this rank file as such. So different arrangements you can actually do, and it will be a sort of completely new kind of a thing here. Just to get rid of these errors, there are a few little problems here. I believe it just doesn't close properly. That's why it's a problem. Yes, it's all good, essentially. We have this setup and it will work perfectly fine. But again, you have that AppDB context setup, and then the real sort of work begins when you use search vector matches and you create that query. So you have your vector, but whatever actually matches your definitions in the DB context, that's what it will be. And you can add another query on top of that, and or as well. So it's not just and or. You can make sure that both of them need to match in order to work throughout all these different elements. And again, that's very useful when you have additional filters to your text query. You can make it very specific or very sort of vague as well. Different kinds of ways you can go about it. And with that said, we will conclude this video.